So, dear students, we'll further go ahead with the topics of estimation, and we have already covered size orientation matrix and function point based matrix basics of all both these software sizing approach. Now, in the previous lecture, we have already discussed about function point matrix, and we have seen that function point matrix actually can tell you about uh, the you can actually calculate the lines of code as well with the reconciliation of the function point and the LOC using language factor. Secondly, we can also estimate the person month efforts along with the total cost. But we actually do not know how to estimate the total time of development, right? It doesn't tell us what is the total time needed to develop a particular project. For calculating the time, we need some mathematical formulas or mathematical representation, which we call as empirical estimation models. The empirical estimation models can be used to complement their decomposition techniques and over a potentially valuable estimation approach in their own right. A model is based on the experience or historical data and takes a form of d is equal to a function of vi, where d is one of a number of estimated values. Like it can be an effort, it can be a cost, it can be a prediction to project duration, and and vi are the selected independent parameter like LOCs or function points. Okay, so this is the basic representation of an empirical based models. Now we will go and see what general formula for this. So in general formula, if this d is representing an effort, then the d will be calculated as we will use some tuning coefficient which might differ with the model that we choose, right? And we will see what are these models, what we why we call this as models. But each of the model has its own turing coefficient as well as its own exponent, right? The size is either determined directly, like from size orientation matrix based matrix, or you can convert it from an FP based system using a language factor. Okay, so when we put this size raised to the power exponent and multiply it with the Turing coefficient, we will get the effort. Likewise, we can also calculate the development time using another empirical formula. So this empirical estimation actually was termed or was used in the reference to most general form most general type of software projects. So the general types of the projects can be classified into three broad categories. One is called organic, one is semi-detached, and one is embedded. Okay. Barry Bohem was the person who actually gave this projects models, right? Which like actually classified the project into the three categories. According to him, we actually divide projects based on the type and some characteristics in these three basic categories. Now let us see what are these categories and why we actually how we find out a project belongs to which of the categories. The project which is called as organic is generally having characteristics that if the project deals with developing of well understood application programs, the size of the development team is relatively small, and the team members are experienced in developing similar type of projects. So we call whenever I have such a scenario, I will consider this as an organic type of project. On the other hand, if the development project can be if the development consists of a mixture of experienced and unexperienced staff. Okay, there are some experienced and some unexperienced staff, and the team members may have limited experience on related systems but may be unfamiliar with some aspects of the system being developed. So in this case, now what is happening is in the earlier case, the organic case, the team has full control or the team has all total knowledge of what they are developing and how they are developing. But in this case, the team knows something that they have done in the past, but most of the like modules or most of the work that they are going to do, they are not familiar with. So in this case, we call that particular project as semi-detached. And the third category is when your project is tightly coupled with the complex hardware or it has a stringent regulation on the operational procedure exist. Okay, there are very stringent conditions that need to be implemented. This is one of hard real-time projects. Okay, so these projects are known as embedded projects. So with these three categories, we come to the start of the estimation project. Estimation model that we are going to discuss is known as COCOMO. COCOMO stands for Constructive Cost Model, and it was introduced by the Barry Boham in 1981. His book Software Engineering Economics. It is one of the widely used estimation model in industry today as well, and it has divided into three basic categories. One is called basic COCOMO, and one intermediate COCOMO, and a complete COCOMO. With the basic COCOMO, we fine tune, we give a very like we give a very vague estimation, okay, a brief estimation about a particular project. But if we want to fine tune that particular raw estimation, we go to intermediate model. And once we're done with, and if we want to have actual estimation, but what will be on the ground estimation values, we go for a complete estimation COCOMO model. So in this particular lecture, or in this course, we are going till intermediate COCOMO only. We are not going to cover complete COCOMO. So the input to this COCOMO can be an object point, function point, or lines of code, whatever the case. But we study only lines of code. As of now, we can also convert function point into lines of code and then give that lines of code as an input to this COCOMO. So converting from a function point to the lines of code and provide giving it correctly to this COCOMO model is left for the students to actually practice. Now, the basic COCOMO model gives as an approximate estimation of the project parameters, or the parameter that we are talking to about is effort and time. Okay, so these two things will be approximately given here. But if we want to find actually, uh, as per your project, what will be the effort and time, we have to fine tune it, and we will do the fine tuning in our intermediate COCOMO model. So the effort estimation is given by A1 times KLOC raised to power A2, right? Where A1 and A2 are the coefficients, okay, or this is A2 is the exponent, and A1 is the tuning coefficient. Likewise, T dev with the development time is given by B1 times effort raised to the power B2, where B1 is the tuning coefficient and B2 is the exponent of the effort. Okay, and A1, A2, B1, B2 are the coefficient. It will depend upon what type of project you are working on. Is it either organic, or it is semi-detached, or it's embedded. They will change accordingly. Okay. TDEV is the development time in months, and effort is the total effort required to develop the product in person months. Okay. Now, the estimation of the development effort is given by for all three basic type of model. If your project is an organic base, the formula is 2.4 times KLOC raised to by 1.05 percent month. Likewise, if you are having a semi-detached base project, then the effort turns to be 3.0 times KLOC raised to by 1.12 as an exponent. But the important point to remember is that this particular parameter, that is the size, is in KLOC. Okay, so you don't come if I give you a value called 1200 is one of the LOC's value. You get this value as an LOC. You will not put 1200 here. Okay, what you will put is 1.2. Okay, because this is in KLOC. Otherwise, you will get an incorrect effort coming out, and that effort will be like totally nullifying your further estimation about the development time. Once you know the effort, we can use this effort to estimate the time that is required to develop a project with that much effort. Okay, so the development time are also divided into three basic categories as per the projects, and but in this case, this parameter remains constant. Okay, this parameter is 2.5. The effort is coming back from this particular equation, whatever equation you choose. If this is organic, you have calculated the word from organic, then the development time will be again organic only, right? It's effort raised to by 0.38, 0.35 and 0.32. You have to figure out a method where you can remember these values. So once you are done with these two, actually we are done with the time that is required to develop a particular project, software project in one of these categories, and the effort that is required to develop the project. Now, this, as we have seen, that the basic COCOMO generally gives only a rough estimate. We want to fine tune it, but what are the parameters based on which we are going to fine tune? For this, this is one of the question that you can pause and you can create a particular type of solution and you can find out what the solution is. Okay, and you can comment uh, as a comment you can ask the answer, and if possible I will reply back. Now, to fine tune this, the basic COCOMO, as we will move to the intermediate COCOMO model. The basic COCOMO model assumes that effort and development time are a function of the product size alone, or you can say the function point or the size alone. We have seen that effort was dependent on the size, and time development is also again dependent on the size. However, a host of other project parameters besides the product size affect the effort required to develop the product as well as the development time. Okay, these are known as cost drivers. So, other than the size, there are lots of parameters actually that do affect the the effort and the TDEV. Okay, so we have not considered them in the basic COCOMO because it was giving a very raw estimation. Now, if we want to fine tune it, we have to find those cost drivers and actually use them in our final estimation. So, what are these cost drivers? So, we divide the cost driver into four categories. One is called product attributes, one is called computer attributes, the next is called personal attributes, and one is called project attributes. Okay. So, in all these four factors, like product attributes can be generally like required software reliability or not. It is the size of an application database is high or less, very less data in a database or a very complex data in the database depends. And it the complexity of the product, what is the complexity of the product. Then we move to the computer attributes. This is the runtime, performance constraint, memory constraint, virtual machine memory volatility, and turnaround time. So these are some of the factors that belongs to computer attributes. Then when we go to the personal attributes, it is like more related to the software engineer or the analyst, application like level experiences or the programmer capability or analyst capability, or whether you have worked on virtual machines or not, or how much experience you are having in programming languages. So we will rate each of the vectors because these factors actually are going to impact the effort and the time of the development. If you are having a very less experience of project experience programming, then you have to learn, then you can implement. Otherwise, you will make the thing worse. And finally, the project manager actually works on the project attributes like modern programming practices. That means what he used. Like if he's asking you to use a try and catch based systems and use of software tools or required development schedule, he is creating a schedule timeline and milestones for actually seeing the project whether it's going right direction or not. So all these cost drivers we are going to impact the effort. So what we do is all these cost drivers are rated based on based on six parameters from very low to extra high, and these values are already fixed. Okay, these values are already fixed, and what we do is we actually what we do we each of these five attributes, if you see, is generally going from increasing from left to right only. Okay, exceptionally, you are having schedule which actually decreases, then again increases. Okay, this is one or two exceptions are there, but generally they are from a very low to high. It's actually increasing only, continuously increasing. Now, what we do is we will find out the project reliability, and we will say suppose it is a high, so we will take this one. Then database size if we say low, and then in product complexity we say high, and storage if we say very high. Okay, now we mark certain values here, and what we actually do is we will, once we have done with all the values as per our own project, we have fine tuned this. Now what we'll do is we will multiply all these uh, values whatever we have here, and calculate the effort adjustment factor. This is EAF. Okay, so in function point, if you want to make sure, you want to remember that in function point we have complexity adjustment factors. What we do is we sum up all the values and create one di, right? Now in this, we don't sum up, we generally multiply all the values and come up with one EAF. Okay, so take an example here. We have this values cost drivers, and for this cost driver they have selected these ratings, and as the rating values are these ones. So what they have done is they have taken all these values and they have multiplied all them and come up to a value called 1.17. Fine. So what you will do is, once you get this EAF, you have to multiply the effort that you have calculated from the empirical estimation model with this AF value. Okay. So the formula will be E will give, this is the initial value. There was A1 and A2 and B1 and B2. So this is AI and BI multiplied by this new EAF value that you have computed using the previous values here. This is EAF value, and once you are done with this, we calculated the the development time of that particular project model. So for organic, the value of A was 3.2, value of B is 1.05, C is 2.5, and D is 0.38. So likewise, you have to actually find some way to remember all these values. So this is how it actually, the intermediate COCOMO actually fine tunes the existing effort. Okay. And furthermore, you can again fine tune it with certain more fine tuning, and when it goes to a complete COCOMO. We are not going to cover complete COCOMO in this particular course. So that was all about software sizing, estimation. In an energy estimation, we have actually seen the size oriented matrix, the function point matrix, how to calculate function point, then how to convert a function point into an LOC. Then once we know this, then we have used empirical based estimation in this lecture. We studied empirical estimation and how to calculate effort and development time initially with my basic COCOMO, and how to fine tune a particular estimation and then use it into a calculating development time using an intermediate COCOMO. So that's all about the complete estimation. Thank you.